ended up, I think I got it wrong at first, and I ended up like, I multiplied the entire top of the person's fraction. Yeah, I was really into it. And when you do it out, I can make a y in the bottom of the graphic minus 25%. You subtract it.
Happy Monday. Short week. Today, tomorrow in school. Wednesday at home. Next week, though, is Monday through Thursday. No, Monday through Friday. So 4 days in a row next week. So they took the virtual day away next week. And then the rest of the year, if there is a day off, then there is no virtual day that week. So like there's a random Tuesday off. So then like that's the virtual day for that week. And the week of Memorial Day, no, we don't go. We're done before Memorial Day. That's right. So that's nice. But just kind of like keep an eye on the calendar just to see, because it does switch like 1 or 2 weeks between April, May. It kind of switches a little bit with the virtual day not being in that week. So really short week for us this week. Today, we're going to look at some applications, trying to create or write our own equations and then solve the system of equations for different applications. Tomorrow, we're going to review factor by grouping and factoring using perfect cube formulas. So the sum of 2 cubes, the difference of 2 cubes, which is that SOAP formula. So that's what we'll be reviewing tomorrow. We have a teeny tiny little quiz on Wednesday, and it is just 3 questions. I have your test to give you back today. Don't let me forget. There will be time. Just somebody remind me if I do forget. So I have your test to give back to you. And like talking about the test, just so you can kind of think about this once you look at yours. I posted the scores yesterday, shortly after 3 o'clock, because I was sitting as my daughter had softball practice. So the scores were posted to Google Classroom yesterday. There is no retest because there's just not time for a retest before break. And coming back after break and not using those identities and formulas, like the retest is difficult to begin with because you're done using them. And taking it after break makes it even more difficult. But instead of doing a retest, I created a buyback opportunity. This is posted. I posted it yesterday right after I put the grades into PowerSchool. So you can read through the directions if you're interested in trying to complete the buyback opportunity. But in a sense, like usual, you have to correct any mistakes that you have made from your test. So you have to perform test corrections, and it's the same test correction format that I always have. So you write the problem number, the original problem, and you make corrections to it. And then if you want to earn buyback points for the Chapter 5 test, I have a worksheet attached. in the same document. And it actually looks pretty much like the test because I have a whole bunch of versions of this test. You guys took one, the people online took one, my period took a different one. I just got a ton of different versions of this test. So these are practice problems. I'm scoring this out of 50 points. And then depending on your score that you receive on the buyback would then kind of depend on how many buyback points you would earn toward your test. So if you complete that worksheet and you get a 94 to 100% on that worksheet, I will add 2/3 of the points deducted back to your chapter 5 test. So if you missed 10 points, then I would add 2/3 of those 10 points back to your test score. If you receive an 86 to a 92%, it's out of 50. So that's why my numbers are a little different here. 86 to a 92, you'd earn half of them back, and then an 80 to an 84, you'd earn 1/3 of those points back. Anything less than that, you don't receive any points. So this is totally optional. It's for you to look at, read through the directions again. And if you have any questions, you can definitely ask me. But this is due Wednesday, 11:59 Wednesday night. So up to you. Again, there is no retest opportunity because it just would be a disaster. I don't think any scores would get any better by doing it after break because there's no way to get it in before then. If you have questions on that, please let me know. But the assignment is posted in Google Classroom for you. So we are going to look at 51 and 33 from the homework. I'm not sure why this is blurry. There it is. And I just want to talk a little bit about 51. And then I also want to talk about number 33 from section 7.2. And then we're going to look at like 2 or 3 word problems. There's 4 examples. We probably won't go through all of the examples. The directions for 51 and 53, those 2 problems, asked you to use a graphing utility to approximate all the points of intersection of the graph of the equations from the system. Round your result to 3 decimal places. You can verify the solutions by checking them into the original system. That's the great thing about algebra. Once you find X and Y, you can plug them back in and check. Or even if you're just solving for X, you can always check. Anytime you have an equation, you can check your work. For number 51, 51 has x squared plus y squared equals 8. What did we say the shape of that graph was on Friday? You have x squared and y squared equal to a number. What's the shape of that graph, Anna? That would be if it was a square root. So that was our square root. I think on Friday we did the square root of x minus 1. So the square root graph is the one that like hooks half of its hooking to one way. Jen, do you remember? Yeah, this one's a circle. So x squared plus y squared equals 8 is a circle. So when you graph it in your calculator, it should look like a circle, but we have to decide how to get it into the calculator to graph. Because it says to use a graphing utility to approximate all the points of intersection. So if we have x squared plus y squared equals 8, how would you go about getting that into the calculator? Kaden, how do you try and take that equation and put it in the calculator? So he said he made it the square root of negative x squared plus 8. So if you get y by itself, you have to subtract x squared. Anytime you plug anything in the calculator, it has to be in y equals 4. And then to get rid of the y squared, we have to take the square root. But anytime you take a square root, in order to get that circle shape, you have negative x squared plus 8. But what goes in front of negative x squared plus 8? Peter? A plus or minus, because anytime you apply a square root to an equation, you're solving for a term that was squared. So you have a plus or minus in front of that, Jack.
That's a negative x squared plus 8.
Yeah, thanks. I missed the squared. Thank you. This quantity here doesn't simplify because it's a quantity. So this doesn't just become x and then plus the square root of 8. So when it's a quantity, when it's a plus sign, that radical stays on the quantity negative x squared plus 8. So in your calculator, you're going to type in the positive square root of negative x squared plus 8, and then the negative square root of negative x squared plus 8. And then you're going to type in that y equals x squared. So you're actually plugging in 3 equations. 2 of them are really the same equation, but to get the calculator to graph it, you have to have the plus because it's going to be a circle. So I need the top half of my circle, but then we need the bottom half of the circle as well. So if you want to take out your calculator, show you what this looks like. So I typed it in as 8 minus x squared, but negative x squared plus 8 is the same exact thing. And then the second one, make sure you're using the negative sign in front of the radical, not the minus, but the negative sign. So if I just type in those 2 equations, mine looks like an oval, and that's because my screen is a really wide. There we go. That makes it look a little better. But it's still oval looking because my screen is a rectangle. But it really is a circle, and that looks pretty close to being a circle. Yeah, that looks pretty good. So there's the circle. So that equation represents x squared plus y squared equals 8. So sometimes looking at the equation and just recognizing what the graph looks like might help get the shape, Peter. It does, but the calculator, for some reason, there are times when it just will not touch 0, and I don't know why. So it's more the technology kind of misleading you, but they do touch, like they connect, because this is a circle and it's allowed to be 0. So I can take the square root of 0. So it does touch the x-axis. It's just for some reason not in the calculator. And then when you go to the y in your second one, no, the third one, you're going to plug in that x squared and then hit graph. Maybe. Come on, buddy. There we go. So x squared is a parabola. X squared plus y squared is the circle. And then use the second trace feature. So second trace, and you're finding number 5, the intersection point. And there's going to be 2. So you have to first find, like I found the intersection on the left first. My calculator is a little different than yours. And this is so small, you cannot see it. But my intersection point is at negative 1.540 and 2.372. And then you'd find the one on the right. But look at your given equation and like before you solve, think what should the shape of the graph be based off of the equation that you're given. Any questions on 51? So I would have used the calculator for 53 and I would have used the calculator for 69. Those 3 problems, you would want to get y equals form and then use the calculator. So 51 and 53, the directions said to use the calculator. And then the last problem, number 69, I would have used the calculator for that as well. Yeah. Yes. Because you're plugging that in and then it's getting squared underneath that radical. So it's becoming a positive value as well. Other questions? All right. So the other one that I wanted to look at was number 33. In number 33, the first equation was a fraction. So x plus y over 4 plus y minus 3 over 3 equals 1. And then the second equation is 2x minus y equals 12. This first equation is still linear because it's just an x term and a y term. So these are both lines. We can use elimination. But before you use elimination, you need to kind of change that first equation a little bit to make it look a little nicer. So how could you take that first equation and get it out of fraction form? So what could we do to get that first equation out of fraction form, Peter? Why'd you use 8? Okay, so he said if you use 8, you could get 2x That would still keep a fraction in the problem, which is fine. But he's thinking if you use 8, then you can eliminate the 2x in one step. Cole, what else could you do? You can multiply by 4. What else can we multiply by? Hayden? 12. So like you're gonna have to multiply by something. And either, any of those, not either, because there are 3 options, any of those options are fine. But to me, when I look at it, I think, oh, I want to get rid of that fraction. I don't want to have fractions in the problem. Jack.
I just rewrote it like as 1/4 x plus 3/4.
So you could rewrite it as well and keep those fractions in. So he said, he looked at this and said, this is 1/4 plus 3/4 plus 1/3 minus 1/3 equals 1. That's what you did, right? And then you could combine all of your terms together. So you combine 3/4 and 1/4, and then you could multiply that way as well. So there, that's a good way too, Jack. Like, so 4 different options we just discussed. It's up to you how you want to approach it. But you could say, I want to take this whole first equation, and Cole said multiply by 4. Peter said multiply by 8. Caden said multiply by 12. Like anything is up to you. Jack chose to separate the fractions and look at them individually. You're going to have to do something to that initial form to try and use elimination. So if you multiplied by 12, the 4 would cancel, leaving you with 3. The 3 cancels, leaving you with 4. So when you multiply by 12, the denominator cancels, but then remember you still have a quantity. So you would end up having 3x plus 9 and 4x minus 4. So whichever method you use to solve, you still have to get the terms on one side. If you use Jack's method, you have to still add terms together and move everything to the right side. If you multiply by any coefficient, again, you still have to add terms together and get things to the other side of the equation. Caden, this is the method you used. What did you end up having with your equation once you multiplied by 12? And then 2x minus y equals, whoops, that's sloppy. Equals 12. So multiple ways to approach the problem, but you had to multiply by something in order to use elimination. So again, it's up to you what you want to multiply by, but make sure that you're understanding that once you eliminate that denominator, it's still a quantity in the numerator. And that term in front needs to multiply by the quantity. Questions with 33. All right. So we are going to, as I said, do a couple of problems from the notes. Our goal today is to see if you can read through an application problem, make your own set of equations, systems of equations, and then try and solve using substitution or elimination. Most cases, we don't really solve applications graphically unless you're asked to do so. Graphically is usually that last resort. Algebra is usually an easier approach instead of trying to graph. So we are on page 5. We're going to look at example 1. Example 1 is more of a business application, and then we'll look at 1 or 2 of the other problems that are on here. So a small business invests $10,000 in equipment to produce some type of product. Each unit of the product costs 65 cents to produce. So to make this product, it costs us 65 cents. And it's sold for $1.20. So obviously we're not going to be making a lot of money here. We're selling something for $1.20. How many items must be sold before the business breaks even? What does it mean for a business to break even, Jack? So the profit equals 10,000. What else does it mean for a business to break even? Anna?
It makes the amount of money that invested.
Yes, so it makes the amount of money that you invest. So how much you're investing should equal the amount that you're earning. So that you're not losing money, but you're not gaining money. So any company wants to, of course, earn money, but you want to at least break even. So the break even point is when your income equals your expenses. So it's an actual point on a graph. When does my income equal the amount that I'm spending, my expenses? So we want to try and create a system of equations to find the break-even point. So if you can kind of think income should equal expenses, then I can create a system of equations to reflect that break-even point. When my X and my Y give me a value where I'm not earning money, but I'm also not losing money. So if you read through the equation, or I'm sorry, the question again, what would our expenses be? So Jack said the $10,000, but there's more expenses than just $10,000. Peter, what other expenses do we have? 65 cents per unit, yeah. So each unit costs 65 cents to produce. So besides spending that 10,000 bucks, you still have other costs associated with this product that we're making. So Peter, how would you write an equation to represent the expenses that we have for this company, business? Yeah, he said U for units. You can use X if you don't like using U. Oops. And then plus 10,000. So 65 cents each unit plus the $10,000 that you had to invest for the equipment that we had to buy. And then how are we earning money? Jeremy, how are we going to earn money? Yeah, $1.20 for each unit that we sell. So if I want to find the break-even point, the XY value when my income and expenses are equal, you can take both of these equations and set them equal to each other. And I'm finding the point where my income and expenses are identical to each other. So what I spent is the same thing as what I earned. And that is the break-even point. So we're not finding a profit margin. We're just finding the point where I'm not earning money, but I'm not spending money. Jack.
Couldn't you also just do like the $1.20 minus 0.65 to get how much you make from each product and then set that equal to?
You could, but that's not a break-even point. So break-even point is when your expenses, by definition, expenses equal income. But yes, that is doing exactly the same thing. Just with like a different phrasing. So you would be finding profit in that case. So if I subtract 0.65 from 120, Peter, you get. And when you divide, you end up. You said 181. Is that what you said? 18,181. So he said he ended up getting 18,181 units approximately, because we can't make, I guess we could technically have a portion of a unit made, the rest of it just sitting in the machine. And then when you plug that back in for the U, Peter, what did you get them for the corresponding Y value? Oh, I guess it just says how many items. Never mind. I guess you answered the question. So if I wanted to figure out my income or my expense, these two numbers would be the same. So I'm making 18,181 units And then my income and expense value should be identical. So that would be the break-even point. At what X value would both my expense and income values be the same? Questions? All right, so let's skip example 2 and look at example 3. We're going to just see if we can kind of set up these systems of equations. So can we write a system of equations? You are offered 2 different jobs selling college textbooks. One company offers an annual salary of $30,000 and a year-end bonus of 1% of your total sales. The other company offers an annual salary of $25,000 plus a year-end bonus of 2% of your sales. Determine the annual sales that make the second option better. So if you're in retail, and we have book companies come to our school very frequently, except now they're selling us a lot of online versions instead of hardback versions. But if you're in retail, you're selling cars, you're selling furniture, you're selling medical equipment. Usually on top of a salary, you end up having some type of amount of your total sales going into your salary, whether it's at the end of the year or at the end of each month. But how much did you sell? You get a percentage of that on top of your salary. Kind of like if you are a waiter, you always end up with tips. So this is kind of like your tips in a way. Our goal is to figure out the annual sales that would make the second option better. In order to do that, we need to write a system of equations first. And you're comparing 2 different offers. So you need an equation for company 1 and an equation for company 2. So, Shiana, how could I write an equation for company number 1 since we're trying to do a comparison here? You're right with 0.01. Do you know how many, like what the total sales was? So you're going to earn just $30,000 no matter what. That's just your salary. And then it says we get 1% of our total sales. Yeah, pick a variable. We can make it X, you can make it S. So 1% of your sales in addition to the $30,000. So the more you sell, the more you make. You sell $100,000 worth of books, and you're going to make 1% of that $100,000 on top of your salary. So Joe, if we then write an equation for company number 2, yeah. Both of them are in y equals form because the y represents your salary. So our salary is y, our end salary. The x is the total number of sales. And then the y would be, what is my salary for the year? And this is something that you might want to think about someday. Which option is better for me? How would you solve this? Like, can anybody explain what you would do to solve this? And how would you solve this? Yeah. Both them equal to each other. And you can solve for x. So we would end up having 5,000 is equal to 0.01x. And then if I take 5,000 divided by 0.01, how much do we have to sell? Oh yeah, sure, question.
Can you do like elimination with it?
Yeah, you could definitely, you can use whatever you want. Yeah, you could use elimination, you can use substitution. I mean, anyway, either way, you could graph it if you wanted to. Any of those methods work. Substitution works because you can just set them equal to each other, but elimination works as well. Anybody know what the number of sales would be, Cole? 500,000. So 500,000 is when they would be the same. If it was more than 500,000, then the annual sales of the second would be better. So it's gonna have to be more than 500,000 to make the second option better. So this is the point where both of them are the same. More than that, then I would want to use option number 2. That seems like a lot of money selling textbooks, but if you're going to a college is going to buy a ton of books at a time. Even here as a math department, like if we buy new books, you're usually buying books for multiple courses, not just one. And each course, you figure you're going to buy a couple hundred books of each course. So when we get new algebra books, geometry books, we'll probably be buying 400 or 500 of each class. You figure each book is $100 or more, plus all the technology that comes with it on the teacher end and the student end. Questions? So for the last example, I just want you to see if you can set up the problem. We won't solve this one, but see if you can set it up. This one's a little different. A total of $12,000 is invested in 2 corporate bonds that pay 5% and 6.5% simple interest. So if you have some type of college savings plan, you probably have money invested in different types of accounts that earn different interest depending on the account it's invested in. It says the investor, the person investing the money, wants to have an annual interest income of $650 from the investments. So you're putting money into an account. The whole goal of putting money into an account is at the end of the year, hopefully you're earning interest on that account. You're earning extra money on top of whatever you happen to invest. And then it says, what is the most that can be invested at the 5% so that I can still earn that $650? This one is totally different than the other 2 problems that we've looked at. So your X is going to have to be the amount invested at 5%, and the Y will be the amount invested at 6.5%. So I'm investing a total of $1,200, but I need to decide what amount goes in one account and what amount goes in the other account. So there's 2 different accounts that we're investing in. So how much should I place in one? How much should I place in another? How could you write a system of equations? Peter?
First one would be 650.
Yes. So this question here, we have 2 accounts. Total, we want to earn $650. The way you earn money on investments is by the interest that you would earn. So maybe I'm earning interest on $5,000 and $7,000. But the interest I earn must equal $650. So this is interest, that's interest, and it has to equal the interest that I earn. We need another equation though, because there's another amount of money, and that amount of money represents the actual amount that we invest. So this is the amount we're earning, but we're investing $12,000. What must that $12,000 be equal to, Peter? Why is it just X plus Y? Yeah, that's the actual amount that you're investing. So maybe I'm investing that $5,000 in $12,000 or $7,000. So each individual investment, I'm total investing $12,000. So the individual investments equal $12,000, but then my interest is 5% and 6.5%. So when you're writing sum equations, you're thinking I'm investing two different amounts. So I have the two amounts and the investment, and then I have those same two amounts and the amount you're earning. A lot of the equations that you'll be writing tonight will be in this form. Peter, would you use elimination for this? Yeah, I'd probably use elimination for this one. Multiplied by 0.05 maybe. You could still use substitution if that's the preference that you have. Questions? All right, so I'm not going to solve this one with you because I do want to get those tests back to you. Your homework is a worksheet that contains, I believe, 8 problems. And the 8 problems are going to be similar to the examples that we did look at. It's posting right now. Yes, so there are 8 problems on here. For each problem, right, a system of equations. So that means you need 2 equations for each problem. And then it says to make sure you define the variables and actually solve the problem. So again, kind of look to see what the wording is. But number 1 is break even. Number 2 is again investing money. So you're investing $20,000 with 6.5% and 8.5%. So that one would be similar to the last example that we just did. And then number 3 is a different job offering. So at least those first 3 are exactly like the first 3 problems that we did in class. And then after that, it kind of switches a little bit. And you'll just have to see what's the wording of the question. So if you decide that you would like to do the buyback opportunity, you can keep this, and then you will give this back to me once you do your test corrections. If you are not doing the buyback opportunity, then I would like this back from you once you're done looking at it. Here. For the students at home, like Evan, I have your test, obviously. And then Darby, I will be sending it back to you so that you have that to look at.
Okay, thank you.
So again, you can look over your test.